All right, last example for lesson 9.1, example 3, use approximate solutions. So we have Anastasia, and she hits her golf ball off the tee. Now, if you've ever been golfing, or if you've ever seen golf on TV, the golf balls kind of form a downwards U-shaped parabola, right? So just kind of be thinking about that. That's what we're going to see in this next example. The height of the golf ball is modeled by the function f of x, and we can see that right here. X is our number of seconds, and I like that this question states that because X is always time. So I want us to make note of that really quick. X equals time. And the question is, how long is the golf ball in the air? Just like before, guys, we are on the search for our x-intercepts. We want to know where we start and where we end on the x-axis, and that's going to answer this question for us. How long is the golf ball in the air? Now, for approximating solutions, we are going to use Desmos. So I want you to pause the video, head over to Desmos, type in our function, and look for our two x-intercepts. Go ahead and pause the video and come back when you have found them. All right, welcome back. Looking at Desmos, it looks like we have two x-intercepts, one at 0, 0, 0, and we have another one at, it looks like we might have to do some rounding, about 5.04, 5.04. Awesome. So what that means, you guys, is the golf ball started at time 0, and it ended at time 5.04. So how long was the golf ball in the air? For about 5.04 seconds. All right, next example. At the next tree, a golf ball was hit and modeled by a different function here. When will the golf ball hit the ground? When we're asking for time, we're always looking for our x-intercepts, our solutions. Go ahead and pause the video again. Head over to Desmos, type in our new function. Just like we kind of disregarded the f of x when we're in Desmos, we can also disregard the equals 0. You only have to type in that part of the equation and go on the hunt for your two x-intercepts. Go for it. All right, looking at Desmos, again, we're going to have to do some rounding here. My second x-intercept looks like at about 1.05. And the other one was at, let's see, negative 0.36. We'll round to the hundredths place for these ones. All right, now when we're talking about time, again, we're always looking at our x coordinates, and those right there are our x-intercepts. Tomorrow in class, we'll talk a little bit about more what these can mean for us. But if you're still feeling a little bit stuck, take a look at this concept summary, and we will review a bunch more questions like this tomorrow in class. Awesome job!